Hello my dear friends. Hello my dear friends, welcome to IMS Academy. I am Sourav and I welcome you live and I welcome you all to the live session of the challenging series. Please let me know if the audio video clear or not. So please let me know if the audio and video is clear or not. So my dear friends, I hope that your preparation is going right on track, and after 2 days you will have gate examination, right? So right now the focus should be on revision and for students who want some good questions by the end of just before the examination, I am here with few questions of few very good questions of industrial engineering, and the session of the duration of the session will be 1 hour, right? So the audio is clear, right? So my dear friends, this is our Telegram channel. You can consider joining in, where you will get all the important updates related to the seminar or webinar, and whatever job notifications are there you will be getting at the earliest, and daily quizzes will also be there, and some lecture PDFs if there, that also we will put. So my dear friends, let us see the first question over here. The question says that in a machine shop, certain types of machines break down at an average rate of 6 per hour. The breakdowns are in accordance with Poisson process. The estimated cost of idle machines is 15 per hour. Two repairmen A and B with different skills are being considered to be hired as repairmen. Repairman A takes 6 minutes on an average to repair a machine and his wages are 8 per hour, whereas the repairman B takes 5 minutes to repair and the wages are 10 per hour. Assuming the work shift of 8 hours, which of the following is correct? A's service should be used, B should be used, both are equally good, can't predict. So my dear friends, I think this pattern of question has been missing in the gate examination, and I strongly feel that such type of question is going to come. This is my gut feeling, right? So I've taken this question earlier also, and now also I think, because this is very very important. So what the question is saying, that two repairmen are there, A and B, they are repairing the machines. Whose service should we consider? Should we consider A's or should we consider B's? So my dear friends, for A, what is the lambda? Lambda is 6 per hour, and he is servicing at 6 minutes in an hour. So 6 minutes he is taking time to repair one machine. So in an hour he will be repairing 10, right? For B, obviously lambda will be same, and how much he is repairing? He is taking 5 minutes to repair, so in an hour he will repair 12. So what will be service utilization for A? Lambda by mu, that is 0.6. What will be service utilization for B? It will be lambda by mu, that is 0.5. Can we find the length of the system? That means, what does the length of the system indicates? That on an average how many machines are there when you check out A in any given hour, how much on an average, how many machines will you find out? So I will find length of the system, rho by 1 minus rho, so that is 0.6 by 1 minus 0.6, so I think it is coming out to be 1.5. What will be the length of the system for B? That is rho by 1 minus rho, so that will come out to be 1. So on an average you will find 1.5 machines lined up at A. On an average you will find 1.1 machines lined up in B. So in an 8 hours time, how many machine hours you are losing? So 1.5 into 8, 1.5 into 8. On an average you will find 1.5 machines lined up with A. So in an 8 hours duration time, how much in an 8 hour duration, in an 8 hour work shift, in an 8 hour work shift, for A the length of the system is 1.5 and for B the length of the system is 1. So 8 hour duration में how many number of machine hours which is lost? Number of machine hours that is lost, that is 1.5 into 8, that will be 12. And how much here? Number of machine hours lost, that is 1 into 8, that is 8. So now you can find the total cost for A. The total cost of A when you are giving A to repair the machines. So he is charging how much? So first of all, the estimated cost of idle machine is 15 per hour. So 1 hour if a machine is not working, so the cost will be 15, and A is taking how much? 8 per hour. So in an 8 hour duration, the cost of A is 8 per hour. So this one will be the wages cost for A, and machine idle cost is 12 hours he is losing. So 12 hours into, and what is the cost of idle machine? 15 per hour. So into 15. You will get something. And over here, what is the total cost for B? What is the total cost for B? This is the total cost for A. So for B it is what? So how many machine hours is lost? 8. 8 into 15 is the idle machine cost, plus what is his charge? His charge is 10 per hour. So 8 hours working and 10 per hour. So we will get something. We will get something. So what is, can anyone calculate and tell me what is the total answer that we are getting? So I think in the first case we are getting 244. What about the second case? We are getting 200. So whose service should we consider? B is costing rupees 200, A is costing rupees 244. Whose service should we consider? So B's we will consider that person's service whose cost is coming out to be lower. So B is the correct answer. B's service we should consider. B is the correct answer. Right? Is it clear? Is it clear? Okay. Please read the next question. Please read the next question. My dear friends, I feel that assignment you should not leave. Assignment questions you should not leave. It's based on a very, particular Hungarian algorithm. If that is clear, so you should not leave at all. Please read the question. Please read the question. So the question says that there are 4 machines W, X, Y and Z. 3 jobs A, B and C are to be assigned to the 3 machines out of 4. The cost of assignment is given below. Find out the optimal assignment. So you know, my dear friends, the Hungarian method or the Hungarian method or the straight line method, which we also say, it is applicable only for a square matrix. So first we need to make it a square matrix, and then we will see what needs to be done. How to make square? We can add dummy row or dummy column. So I think one row is missing, then it can be made 4 by 4. It can be made 4 by 4. So let's make it a dummy, let's add a dummy row. So I can add here D, and I can write here 0 0 0 0. So I've added a dummy row. Hello Atul. I've added dummy row, and after that what needs to be done? After that we can apply the straight line method or the Hungarian method. What is that method? That from every row you have to select the, we have to subtract the minimum element so that it contains 1 0, and from every column we can subtract one element, the minimum element, so that after the end of row reduction and column reduction we have 1 0 at least in every row and every column, right? So what is the minimum over here? So minimum is 18. So okay, so minimum is 18. So let me write it over here. So it will be 0, then 24 minus 18 will be 6, then it will be 10, it will be 14. Then over here 8 is the minimum. So 0, 5, 9 and 10. 10 is the minimum. So 5, then 9 and then 12 over here. No need to do column reduction because already all the elements are 0, right? So this is after column reduction, after row and column reduction, after row and column, after row and column reduction, after row and column reduction. After that what needs to be done? The third step is allocations. The third step is allocations. Now what is the rule? The rule is that we will start from row 1. If there is 1 0, we will do the assignment. If there is more than 1 0, we will skip. So let's say this is the first row, only 1 0 is present, so I can do the assignment. I can do the assignment. And below whatever zeros are there, we can cancel it out. Second row, no 0. Third row, no 0. Fourth row, multiple zeros, skip. Repeat for the column now. So already 1 0 assigned. Second column 1 0 I have seen, and I will do the assignment. And in the corresponding row, extra zeros you remove it out. Again third column no 0, fourth column no 0. So either all the zeros, after allocation all the zeros are either allocated or crossed off. Now what to do? Now we will see that if the number of allocation is equal to the order of the matrix, the assignment is optimal. But it is not over there. Order of the matrix is 4, the number of assignment is 2, so it is not optimal. So what we need to do? We need to make it optimal, and for that we will use tick untick method. For that we will use tick untick method. So what we have to do? Using the minimum lines, we need to cover all the zeros. Using the minimum line, we need to cover all the zeros. So what is that tick untick method? Just tick mark wherever no allocation has been done, right? Now in the ticked row, just come out where there is no allocation and tick the corresponding column, right? take the corresponding column. So for this also this, for this also this. Again corresponding column you go to, again wherever you have ticked in the column, see where allocation is done and tick the corresponding row. Again in the row you see where allocation has not been done, tick the column. So no, I am not finding anything in the first column, no unallocated 0, so I will stop it right here, right? And finally you cross all the, you draw lines from the unticked row and ticked column. So what is unticked row? The unticked row is this one, and what is ticked column? It is this one. So when I cross it out, you will realize that all the zeros have been, you know, covered, and the number of lines is equal to the number of allocations that you have done. So number of allocations I have done is 2, so number of lines is 2. That means we are going on the right track, right? From there, now whatever is the remaining element is there, you select what is the minimum element. The minimum element over here is 5. So wherever no allocation, the, you know, no element, whatever elements are passing through no lines is there in whatever elements, you subtract that minimum element from there. So 6 minus 5, it is 1, 5 minus 5 is 0, 5 minus 5 is 0, then just subtract 5, 4, 4, then 9, then 5, and then 7. Now from where intersecting point is there, you add that element, so I am adding, and from where only one line is passing, you just write those elements as it is. Right? And after that you again start allocations. So first row 1 0, I will allocate, remaining I will cross it out. Second row 1 0, allocate, remaining cross it out. Third, no, then again come to fourth, 2 zeros, skip, again come to, you know, again come to the column, already allocated, 1, right? Right. So again I am finding that again it is, you know, number of allocations is how much? 3. What is the order of the matrix? Order of the matrix is 4. So that means it is what? It is not optimal. It is not optimal. It is not optimal. Not optimal. So what we have to do? Again we have to, you know, tick untick method. So wherever no allocations is done, you just tick mark. Then tick the corresponding column. Again go to the corresponding, tick the corresponding, you know, allocated row, right? Tick the allocated row, and finally the chain of ticking stops, and finally you draw line through unticked row and ticked column. So unticked row and ticked column, right? Now from here whatever is the minimum element? 4. What is the minimum element? 4. So you subtract 0, 0, 1, 5, 1, 3. Intersecting elements you add, so 9 and 4, and only single line you write as it is. Right? Right? And finally you again start allocations. Allocations, right? So how to allocate? How to allocate? How to allocate? I'll start from the first row. 1 0 if I am finding, I'll allocate. Extra zeros you cross it out. Second row 2 0 skip. Third row 2 0 skip. Fourth row 2 zeros skip. Again column. Again column. So I can allocate 2 0 skip, 3 0 skip, 1 0. You just allocate. Then extra 0, cut it off. Again go to row wise. Row wise you can allocate this one, and you can cross it out. You can cross it out, and you can allocate this one, and you can cross it out, right? So finally how many allocations have been done? The number of allocations is 4. And what is the order of the matrix? The order of the matrix is also 4. Now I have to rush it over here for solving the questions, because the theory I have already discussed in very much detail in our the smart revision series or the concept series. So here what is the allocations? So you can see clearly that A is allocated to W. A is allocated to W, B is allocated to X, C is allocated to Y, and that's it. So what is the minimum cost? The minimum cost over here is 18 plus 13 plus 19. So it's coming out to be 50. What is the minimum cost of allocation? It is coming out to be 50. I hope it is clear. Okay, check out this problem. Please check out this problem. Please check out this problem. So what this problem is saying? What this problem is saying? So the problem is saying that given annual usage is 8,000 parts, the cost of placing an order is rupees 150, and the annual inventory carrying cost is 30% of the unit price. For the variable price schedule given below, the most economical order quantity is dash. So what is the question saying? The question is from price break. And my dear friends, let me tell you, price break is very, very important. Price break questions are very, very important as far as industrial engineering is concerned. On an average, you will be getting around 4 to 6 marks of questions of industrial engineering. And by the end of the session, I will also tell you what are the important chapters which you should focus more on, right? So my dear friends, what is the trick? The trick is, first of all, we will write what is annual D, that is 8,000. What is C naught? C naught is rupees 150. And what is the CH? CH is 0.3 of the unit price, and unit price is given. For the variable price schedule given below, the most economical order quantity is what? Now my dear friends, I will always start from the lowest unit price. Yes, that is the trick. We will always start from the lowest unit price. The last unit price we will start with. So what is the last unit price? 56. So considering CU is equal to rupees 56. So what will be CH? CH will be 0.3 of 56. And what we are getting? We are getting 16.8. We are getting 16.8 rupees. Now considering this, you will find the economic order quantity. So what is the EOQ? Economic order quantity. That is 2D C0 by CH. So 2 into capital D is 8,000, and what is C0? 150, and what is CH? 16.8. What we are getting? The Q star answer that we are getting is 377.96. 377.96. Now my dear friends, if this is falling in the feasible range, if this is falling in the feasible range, this will be your answer. If this is falling in the feasible range, this will be your answer directly. No need to check for the above unit prices, right? But is this falling in the feasible range? 377, is it falling? No, the lot size is, this is valid only for 501 and above quantities. 501 and above quantities. So it is not feasible, so that is wrong. That is not feasible. It is not feasible. It is not feasible. So what we will do? Again we will go to the above unit price. Now the unit price is 60. Now considering unit price of rupees 60, rupees 60. So what will be CH? It is 0.3 of 60, that is 18 rupees. 18 rupees. Now you find the Q star. Now you find the Q star. To D C0 by CH. What is capital D? 8,000. What is C0? And what is CH? 18 rupees. Now what is coming out to be? Now what is the answer? 365.14. 365.14. Now you check whether it is falling in the feasible range or not. Now you see whether it is falling in the feasible range. 365. Yes, it is falling. Yes, this is falling. So this is feasible. This is feasible range. So now since it is falling in the feasible range, shortage question next please. Okay Shreya, we will take shortage questions also. Okay. So since it is falling in the feasible range, so that means we will consider it. We will consider it. So this quantity and the quantity where price break started, the price break happened, the lower one, that will be your comparing quantities. That means those are the two quantities where you will compare, right? So I will compare 365 and I will compare 501. That means you have to find the total cost. So total cost at EOQ, that is Q star as 365. So what is the total cost? That means the annual demand into unit cost plus, now since this is EOQ, I can apply the formula root over 2D C naught CH. So what is capital D? 8000. What is unit cost? 60 plus root over 2D C naught. What is C naught? 150. And what is CH? 18. So if you find it out, what we are getting? What we are getting? 486572. 486572. Right. And what is the total cost at 501? What is the total cost at quantity is equal to 501? So again D into CU. So D is what? D into CU. Now plus I cannot use this formula for 501. Why? Because this is not EOQ. This is not EOQ. This is not EOQ. That's why I cannot use this formula. So what formula I will use? I will use the very general formula. The general formula is, number of orders into the ordering cost plus average inventory into the holding cost. I will use this formula. So what is capital D? What is the corresponding CU? 56. Capital D is, Q is what? 501. That is the ordering cost that we are writing. C naught is 150. What is Q? Q is 501. That is the average inventory, and the holding cost is 16.8. So if you calculate this one, how much we are getting? 454603. 454603. In decimal also we are getting. So out of these, which is the lowest cost? Which is the lowest cost? So clearly this is the lowest cost. So what will be the EOQ, or what will be the quantity at which we are getting the optimal order quantity? That what is the optimal order quantity? 501. It is 501. The optimal order quantity is 501, right? And he can also ask what is the total optimal cost. He can also ask what is the total optimal cost. So corresponding cost you can, corresponding cost 454603, right? Chalo, theek hai. So here's the next question. Please read it. This is from, I think, shortage only. This is the mixture. This is the mixed question. That means everything is there. Consumption is also there and shortage is also there. Please read. Please read what the question is saying. So the question is saying the demand for an item in a company is observed to be, so annual demand is given as 15,000 per year, and the production capacity of the plant is 2,000 units per month. So it is 2,000 per month. So this is per year. So if I have to get it per month, what will I do? I will divide it by 12. I will divide it by 12. Per month. Okay. The setup cost is rupees 800. The setup cost is rupees 800, and the inventory holding cost is rupees 25. So what is the holding cost? Rupees 25 per unit per year. Mind the units. The shortage cost of one unit is given as 250. So what is the shortage cost? It is given as 250. Determine the economic batch quantity and the cycle time. Determine the economic batch quantity and the cycle time. Now why I have taken this question? Because in inventory, in the deterministic models, there are 4 models which comes under deterministic. Out of that, for the first one is what? Wilson-Harris model, that is the basic EOQ model. Second is what? Second is production consumption model or manufacturing quantity, manufacturing model, and third one is shortage model. So the shortage model, if it is the question has come, it is purely on shortage. If a question has come from production consumption, it is purely on production consumption. But this is a question where production consumption is there plus shortage is also there. That means it's the question of 4th model. It is the question of 4th model, right? So that means I think they might give this one. Till now they have not given such questions where all is there, all is involved, but I think this might be given. And also cycle time, how to find in the 4th model, how to find. For example, I'll just take 2 minutes of time. The graph in the basic EOQ model is this one. The graph in the manufacturing or the production consumption is this one. The graph in the purely shortage model is this one. And what is this question? This question is that production consumption is also there and shortage is also there. That means this is the question based on this. And here if I am asking you the cycle time, then what to do? So always remember cycle time is whatever is the demand divided by what is the ordering quantity, right? What is the cycle time formula? What is the cycle time formula? In one time, see, in one cycle, what is the cycle time? That means whatever you are setting up, whatever you are using in a cycle, that is Q star, whatever we are using in a cycle, that is Q star, and what is the rate at which you are consuming, that's it. Only one formula of cycle time is there which will be used throughout. Don't think that we have separate formulas for different cycles. What is in one cycle, how much you are consuming, Q star, and at the rate at which you are consuming. At the rate, that means it is units, the unit, that means it is the number, and what is D? Unit per time, that is the rate of consumption. So time will go up and it will be cycle time. Okay. Now coming back to this question. So what is the first we have to determine what? First we have to determine what is Q star, and then we will use the formula to calculate what is cycle time. Two things. Two things we are calculating. So you just need to remember what is Q star. You just need to remember what is Q star. Formula. So 2D C naught by CH into P by P minus D into CS plus CH divided by CS. This formula. And whatever is given, you just substitute. Whatever is given, just substitute. So this is giving out to be 15,000. C naught is how much? Sorry, we are setting up. So CSP, we are setting up. So CSP 800. Holding cost is how much? 25. Now see, I have kept the unit of this capital D and this CH in terms of per year only. If it was per month, I need to convert it in terms of per month. So mind it, mind the units, mind the units. Now what is P? Now this I will keep only in terms of month. Month and month will cancel it out. So P is 2000. And it is 1250. Now what is shortage cost? 250. So 250 plus 25 divided by 250. Now you substitute everything, and what is the answer? You substitute everything, and what is the answer? 1678. 1678. 1678 units, right? And he is asking what? Cycle time. What he is asking? Cycle time. So what is cycle time? As I said, we have only one formula, that is Q star, and what is the annual demand, that is the rate of consumption. Annual demand is also rate of consumption. Annual demand is also rate of consumption. So Q star is what? Q star is 1678, and let's say you have substituted 15,000. Now what is 15,000? What is 15,000? You will say annual demand. I will say rate of consumption. That is same only, because this is the rate per year. It is 15,000 per year. So year will go up, and what it is coming? 0.11187. 0.11187. But what is the unit? Years. But this is not very comfortable to express it. So you will do what? This is not very much comfortable, eye pleasing. So you will multiply by 12 and write in terms of month, and that you will get as 1.342. 1.342 months. Clear? Clear? Is it clear? So what did we learn over here? That whatever model it is in the deterministic model, whatever model it is, just remember that the formula for cycle time remains the same. Is it clear? Okay. Read this one. Please read this question. So what the question is saying? The product structure of product P is shown in the figure below. The assembly of 2 units of B and 4 units of C to produce 1 unit of A takes a week. The ordering time of B, C and D are 2, 1 and 2 weeks. The master production schedule for product P is as follows. So my dear friends, see, it is the question of bill of material, and BOM questions here and there we can definitely expect. So for week 6, 7 and 8 the demand is given, and you know this is the chart that he has given. The net requirement of C if initial inventories of A, B and C, D are. Now this is important, this data is very important. So tell me one thing, what is the net demand? What is the net requirement of P, the main product? What is the net requirement of the main product? What is the net requirement? What is the net requirement of the main product, that is P? You just add all the demands. So if you add all the demands, it will be 80. So for product we need to order P how much? 80. We need to order how much P? 80. So finally he is asking the requirement of C. So is C present over here? No, C is present over here. So I have to pass through A. So for 80P, 1A is needed. 1A is needed to make 1P. So 80A will be needed to make 80P. And should I order all the 80A? No. He has already told that A is already 10 present. Already 10A is present. So how much we will order? We will order 80 minus 10, that is 70A. 70A we will order. Right? For 1A, 4C is needed. For 1A, 4C is needed. Therefore, for 70A, 70 into 4, 280 C's are needed. But will we order all the 280? No, already 15C is present. Already 15C is present, but already 15 C's are in on-hand inventory. Therefore, number of C to be ordered is how much? 280 minus 15, that is 265. 265 C's we will order. 265 C's we will order. So answer is what? 265. Clear? Okay. Please read this one. Please read this one. Please read this one. Now this is a question of primal to dual conversion. This is a question of primal to dual conversion. This is a question of primal to dual. Again, primal to dual we can expect for 1 mark. For 1 mark we can definitely expect. So given primal, find the dual of this one. So you know that whenever primal is given, it is given in the standard format. What is the standard format? Maximization z less than equal to constants is the standard format of primal. What is the standard format? Maximization problem and less than equal to type of constraint. So what are all the constraint less than type? No, this is not less than type. This is not less than type. So we have to convert it in less than type constraint, and for that we will multiply with minus. Initially it is not in less than type, so we have to convert. And how to convert? We have to multiply by minus. So I am writing here only. So minus 2x1 minus 3x2 minus 2x3 less than equal to minus 6. Now you can apply whatever you need to apply. So let me write the matrix. Maximization will become minimization. Maximization will become minimization. So C and D cannot be the answer. C and D cannot be the answer. Why? Why? Because maximization will become minimization. So A and B is left. And now I am writing the, the matrix. Minus 2, minus 3, minus 2. Then 3, 4, x3 is 0. Then 6, minus 4, 1. Now you take the transpose. Now you take the transpose. If you take the transpose, what it will become? Minus 2, minus 3, minus 2. 3, 4, 0 and 6 minus 4, 1. Now assume that corresponding to this constraint, your dual variable is y1, corresponding to this it is y2, corresponding to this it is y3. So write here y1, y2, y3. So what will be the equations? And if the primal is in less than equal to type, the dual will be greater than equal to type. Maximization will become minimization, less than equal to will become greater than equal to. All these things are there. So minus 2 y1, minus 2, what will be the dual? Minus 2 y1 plus 3 y2 plus 6 y3 greater than equal to. And now see what is the coefficient of the objective function over here, 4. So that will be the answer. Again, minus 3 y1 plus 4 y2 minus 4 y3 less than equal to becomes greater than equal to. And what is the coefficient? 2. Again, what is the coefficient? 6. This is the equations. Minimization W. Minimization W. Now whatever is the RHS over here, what is the RHS? Minus 6, 8 and 10. So that will be the objective function, that will be the objective function. So minus 6 y1 plus 8 y2 plus 10 y3. This becomes your final, and obviously the non-negativity constraint will be there. The non-negativity constraints is always there. So which option is matching now? Which option is matching? I think B is matching. Yes, B is matching. So B is the correct answer. B is the correct answer. So apart from knowledge of the topic, you also need to be aware of some options elimination also, right? Remember, it is not a battle of your knowledge, it is the battle of how fast and how many questions you are able to do it correctly in a specified amount of time. That is the 3 R's. So I told you that I'll tell you what are the topics which I feel is super important from the examination perspective. So let me tell you that network models, you cannot think of skipping. Network models in transportation, let me write it. So topics which I feel is super important is entire network models. Entire network models. Then in linear programming, I feel graphical method is again very important. Graphical method and assignment problems, which I feel is very important. You should not skip the assignment problem, and it's very easy. Whatever I am writing here, they are all 1 hour topic. If you know the concept, then it's fine, just move on. Then third is what? Third is inventory. Now in inventory, there are 4 deterministic models which you need to know the concept. Then there is 4 deterministic plus price break model, and 2 probabilistic model. And fourth one is queuing theory. And obviously you know that in queuing theory 2 distributions are very important. What are the 2 distributions? Poisson's distribution plus exponential distribution. And after that, performance parameters are there, and very easy formulas are there. Performance parameters. So obviously every topic is important, and we cannot say with certainty that this will come, but I feel that these are the super important topics from the examination perspective. At least you should always keep in mind this, and this will, if you have studied once, so this should not take much time to revise as well. Rest, whatever you have studied, that is important. That means transportation I have not written here. Transportation you will study. Simplex I have not written. Simplex you might have studied. Then break-even quantity I have not written. That is also over there. MRP, bill of material question, that is also over there. Line balancing I have not written. That is also over there. Lean manufacturing, a theoretical topic is there, that is also there. So many topics I have not written, but these topics I feel that there is a very high chances that questions will come from this area. And if you are particularly if you are studying, if you want to ask me what is those topics which I should pay more attention, then these are the topics, right? So with this, it was a 1 hour session. So I wish you all the best, and I think that if you have studied well, if you have revised well, then you just need to maintain your calm and focus on solving more and more questions accurately and correctly, right? So with this we end the session. All the very best. See you tomorrow with the challenging questions of heat transfer, right? So goodbye. God bless.